Hello guys, in this video we're gonna talk about the second part of lab 3. Also we're gonna use our lab manual. In this video I'm gonna walk you through the important things that you need to complete the lab. So I'm not gonna demonstrate the full instruction. After we follow the lab manual instruction in part B, there is a time where it says add file to design, and this option is not always what we can find here. So if we found it gray or hidden or clickable, we can go and right click on the full adder, then click add file to design, and that way we can use the files, especially for the first time. If we find it here, we can use it. Usually it's something like this, the gray thing, the second thing. Next, I'm gonna add the files and they keep going on. If when you add the files, you should be able to see them in this window to the left. So if you add them and you didn't see them here, then you're still having an error. This is very also important thing. Next thing I want to do is we not use the compile all with file reorder, the one that I just clicked, because that sometimes gave us error or something. We just use the first two compilation. Next thing is when we click on this one, these arrows, we can use this one in order to take it to the left, or we could use the double arrow to take all of them to the right or to the left. And by now you're already familiar with this. Everything is mentioned in the lab manual. If we came to add a top level unit and we couldn't find anything, that's mean you are not compiling. So what you need to do in order to fix this is either you click recompile from here, or cancel this window, which I will do, and then I will go to this one, the two things. This is compile, or the one next to it with just compile all. Right now I click on compile. Next thing, you need to check that the compilation has been done through this window, which is very important and handy. And now if you go here and then you click choose, you will find the top level, and this is for everything. Important thing, don't leave any spaces, so always delete everything and then add it. By now you should be able to complete all the way through till part C. Before we run into part C, let's talk about the simulation. If you set the simulators correctly, you should be seeing something like this. At this time, we have this button, which is zoom to fit. But in order to see really what's going on, what we need to do is use this button or this tool, handy tool, which is gonna expand the timeline for us, and it's gonna show us exactly what each signal should be, or what's its value at this time. Later I'm gonna show you a way of dragging like the red bar or the red line in order to see how that's gonna tell us very good way of the results, or a very good way to see the results and explain it. So the first line, which is B, as you can see, it's incremented by 1. So that's, I hope by now you understand why we choose a counter. And we set it from 1 to every 20 nanoseconds. So from 0 to 7, that's 8 times or 8 cycles. And 8 times 20 is 160 nanoseconds, and that's why we set A into 160 nanoseconds. So as you can see here, from the beginning we have 0 to 7, and then all of that with A being 0. when they are start repeating or the cycle start to return, the a incremented to 1. In the line here that I'm showing, which is the S, it's abbreviation for sum. When we have 0 plus 0 give us 0, 1 plus 0 gives us 0. Keep in mind that the Cn is currently 0. So this way we want you to read the results or to try to explain them to yourself. 4 plus 0, 5 plus 0, and so on. The next thing is when we're gonna move, we entered a equal 1. So here we have a curry because 7 equal 1, and I want you to go all the way and then check the results just for yourself to understand better. Important thing is, which is right here, where the Cin gonna come in. You see that little red thing, which is the flickers happens that usually we don't see or we don't sense, but it is very important that you look into it. So I want you to go through it and discuss it. Ask me or ask the TAs in the room about it if you have any questions. Hopefully you can get same results. Remember that this is just 1.28 microseconds in order to do the full thing. Important thing is you can the red line, which is the very important, show you the results exactly at right here, but I would prefer the other way, which is going through one by all of it, but feel free to use this one also. It's going to give you, for example, here 5 at B, 0 at A, and then 5 S, and it's also showing you exactly how much the second is. We can also expand the B because it's a 3-bit or 3-digit number. So we can see A000, like B5, it's 101. And same thing for the summation. So I hope that could give you like a good explanation about why the simulation is useful for us, because show us very important details. Now, when we reach to part C, don't freak out because it's a big or complicated circuit. All what we care about is the inputs and the outputs. If you set those correctly, everything should be easy to fix. But please don't make a mistake in the name or in the inputs or the outputs, because this is very important. Let me complete the circuit and then come back to you. So here, as you can see here, I completed the circuit, did everything, but there are a couple things that I want to talk about. One of them is we already know what's the difference between the wire and the bus. When we connect a wire into a bus, we need to name that wire. But when we gonna make a connection between the input or the output in this case, which is, as we can see here, which consists of 7 wires or 7 outputs, into an output that also contains the 7 wires, and we don't need to name that bus. Why? Because it is the same number of outputs going from the 7-segment display is to the output of A to G 6 to 0 on the other side, which is what we can see here. So it's an array of wires that's going directly in a well-prepared way. So we don't need to name this. Only in this case. Only when we have from the 7-segment display or from another unit or from another chip into a direct output that's having the same numbers. What do I mean by that? Let's say, for example, that we do have this a bus is connected to two types of switches: A from 2 to 0 and B from 2 to 0. Now both of those gonna be 5 to 0, which is the bus of S5 to 0. But we have to name those because it's different than uh, that one. It's not going to just one output or not just one wire. Same thing for AN, we don't need to name it. And for the DB, it's just like just a single wire. So this is very important. Please don't be confused about this. Okay. Next thing I want to show you, which is where we place the ground from. So we go here, we click on this one, and then we choose the ground. Or we could just type the letter G on the keyboard and it will give us a ground. We could remove the extra that we don't need, and we could do just like the delete button. Or as you can see here, I just press G and it's gonna be attached to the mouse, and then I always need to go back the cursor. Now let me show you how we could create the compound bus, which is the very complicated one. So I jumped ahead and used the harder circuit. So because I want you to do for the previous circuit that we didn't complete yet. First of all, you need to make all the buses that need to be connected to that compound bus. Give them names. Right now, as you can see, the ones, the tens, the ground, with the proper names, all of them. And then you need to name it exactly in order that you can see it in the lab manual. What do I mean by that? So let me zoom in first. The first thing that you're gonna do is, first of all, you're gonna name the ones, and then the tens, and then the ground, and then as you can see, I made all the type of buses. Then finally, the last thing is you're gonna grab that bus and you're gonna go to the top. Let me adjust my screen a little bit. So as you can see, it's a simple bus. Then you're gonna switch it to compound bus. Then you're gonna click here, and then you're gonna start by an order. As you can see here, it's a start by the G7 to 0. Remember that I'm using the last page, so it's part D. And here, when you go by this drop menu, you can see there is an options of what? Of G7 to 0, T3 to 0, and O3 to 0. Now, as you can see here, the name, which is linked to the compound bus, is exactly as you can see it on the picture. So don't switch the positions of the name of the, for example, the G70 with the T30 or something. And then, as you can see, if we move it, we're gonna be able to switch all the buses that connected to it. This is the important thing. And now, as you can see, I implemented the circuit for part C. And on the same way, I'm gonna upload the bit file, the file that .bit, which is the other 3-bit top to the FPGA board, and then we're gonna see how we gonna work with that. First, I'm gonna go back to the file and make sure that we understand one thing, which is we're gonna use the switch 5 to switch 3 as A inputs and switch 2 to switch 0 as B inputs. Also, we're gonna use the button 0 for clear and button 1 for carry in or CN. Let's go and see what does that look like. We don't need to worry about the outputs because we're gonna use the 7-segment display. So here we go. This is our base 2 board, and let me zoom in. for a little. Yep. So this is a switch 5, and this is gonna be A2. Switch 4 gonna be A1. Switch 3 gonna be A0. Switch 2 gonna be B2, B1, and B0 from switch 2 to switch 0. Uh, so if we wanna represent this case, for example, which is 1, 0, or let's start by simple case. 0, let's say the Cn 0, so we are adding 1 plus 3. So how much we should get? We should get 4. So the Cn is 0, so we don't need to worry about this. And then we have 0, 0, 1, which is 1. And then 0, 1, 1. So that's going to give us how much? 4. Because 3 plus 0 and it's give us 4. And remember that we didn't press on the push button because it is 0. Now we're going to do the other case. I written all of them to 0. And then this case is how much? Which is 0, 1, 1. And also here we have 1, 1, 0. So 6 plus 3 is 9, plus 1, the carry in. As you can see, I need to keep pressing on the push button. It's gave me A. And remember, this is in hexa. Okay? And same thing, we're going to fill the table. For example, 6, the next one, 7, sorry, plus 5, which is how much? 12, plus 1, the Cn. This should give me 13. So 1, 1, 1, then 1, 0, 1, and then I need to press on what? On the Cn. Then here we go. It gave me D, which is correct. And in the same way, you're going to complete the rest of the table. Now in part D, I would like to mention an important thing, which is as you can see here, I almost completed the entire circuit, but I want to show you from where we could grab the continuous assignment 1. We go here and click on the C, and then we just place it wherever we want by just single click. And then if we go back to the cursor, we could drag and hold to put it wherever we want. And then hence right now it's attached to the gate, so it's draw the bus automatically. If don't, you could just grab it and then hold it. And then if you drag and hold and the bus is still attached to it, then that's it. You don't need anything to do. It is connected. This green line is kind of the way that we want to activate the circuit with, or the path that we need to code in. So it's, as you can see, assign, and then strength, which is represent the B as an input, and then equal sign to identify which exactly what we need to do, and then last the H6. So please don't change this to any special character or something, because it's a program to be working as it is. Finally, after you finish the circuit with the proper names and everything like that, you should be able to see what you're gonna see in a little bit from results. One important thing is you need to do the compound bus as we agreed on. If you don't know how to do that, please go back into the earlier section of the compound bus. As you can see here, I'm gonna go into this, check everything is correct, then I'm gonna go into the simulation. This, you need to compare this simulation with what you have in the pre-lab, and give an explanation if it's different than this, or if you have an error or something like this, or you could ask us in the your lab session. And now as you can see, I completed the last section of the lab. And now I synthesized and I implement successfully, as you can see, which is an important. And now I just check the main switches that I'm gonna use, and it's the same switches, so switch 5 to switch 3 and switch 2 to switch 0. And here we're gonna use the table, which is 3.2, and make everything is 0, as you can see here. And then take a couple cases and then try to get the results from them, and you need to do that while you are in the lab. So here 2 plus 2 equal 4. In the same way, you can complete all the cases. That's it for this video, and thank you so much. That's the end of this video. I hope that you enjoyed.